In this video, I am going to go over with you all of the heat-related questions from the 2019 Chemistry Regents exams. Let's get started. We're looking at 16 and 17. For question 16, which form of energy is transferred when you have an ice cube at 0 degrees Celsius placed in a beaker of water at 50 degrees Celsius? The only kind of energy here, folks, that we're going to be talking about is thermal energy. It's a fact. You need to know it. Let's go to 17. The average kinetic energy of the particles in a sample of matter is always expressed as temperature. The definition for temperature is going to show up a lot. More than likely, with whatever regions you're going to take, you're going to see it too. Moving on to one more question from the January 2019 Chemistry Regents exam. We are looking at question 41, and it's asking which numerical setup can be used to calculate the heat energy required to completely melt 100 grams of water at 0 degrees Celsius. If I'm going to melt, I need the equation on the reference table. Let me show you where they are on reference table T. We're also going to need the constant for melting. We're going to check that out also, and then we'll get back and answer the question. You're looking at the 3 heat equations that you need to know. They're on reference table T. Now, if we're dealing with melting or freezing, we are dealing with heat of fusion. With heat of fusion, I'm going to use Q is equal to MHF. One of the things that you want to remember, anytime that you have a phase change, temperature along with kinetic energy is held constant. You do not have a delta T. Let's go back and let's use this, although we want to check out what the heat of fusion for water, what the constant is. It's on the front of the reference table. All right, you're looking at table B on the front page of the Regents Chemistry reference tables, and sure enough, for heat of fusion, we're talking about 334 joules per gram. Let's go back. All right, for question 41 then, you see I wrote the equation down. I'm going to take the mass of water, which is 100 grams, and I'm going to multiply it by the heat of fusion, which on the reference table B is 334 joules per gram. In other words, my setup is choice 1. That's it for January 2019. Let's go to June. June 2019. Regents, let's check out question 17. It's asking, during which 2 processes does a substance release energy? That means it's exothermic. Now, the way I always remember it is this way. I would write solid, liquid, gas. And I know that if I have a solid and I want to melt it, I have to put energy in. In other words, or if I have water, for example, I'm going to boil it, I have to put energy in. That means the way that I set up solid, liquid, gas, the arrow to the right would mean endothermic. But we're talking about releasing energy, which is exo. We're going to want to see phase changes that are working in the opposite direction. What phase changes are they? Well, gas to liquid is condensation, and liquid to solid is freezing. Do we have them both, condensation and freezing? Check it out. It's right here in choice 1. It can't be choice 2 because with melting, I got to absorb energy. It can't be choice 3 because evaporation, again, absorbing energy. And for choice 4, evaporation and melting, absorbing energy. 17, the answer is choice 1. I base it on what I know already before I even walked in the door for a chem class. And if I'm going to melt something or I'm going to boil something, I got to put the energy in. That means the opposite, the energy is coming out. Question 41. We're looking at the amount of heat absorbed when the temperature of 75 grams of water increases from 20 to 35 degrees Celsius. I'm looking for heat. That means I'm dealing with the heat equations. That means I got to go to reference table T, and then remember the constants on reference table B, the front of the reference tables. I do have a delta T. I have a starting and ending temperature. That means the equation I would pull off of reference table T is Q is equal to MC delta T. I always recommend, even though you don't have to show your work, write the equation down for multiple choice. My mass, 75 grams. My specific heat capacity is 4.18. Delta T, 35 minus 20. Look, plug everything into the calculator. You don't want to make a silly mistake. You're talking about 15 degrees Celsius here. You multiply these three numbers together, and you're going to see on your calculator 4702.5. When I round that to 2 sig figs, we're talking about choice 2. That was it for the June 2019 Chem Regents when it comes to heat and calorimetry questions. Let's move on to August. Wow, I found one question related to heat and calorimetry on the August 2019 Regents exam, and that is question 57. This is a part C question. You get information a lot of times above the questions, and there's 3 questions here. We're going to just focus on 57. 58 and 59 have to do with other parts of the chemistry course. You have a 100-gram sample of liquid water heated from 20 to 50 degrees Celsius, and you also have enough KClO3 dissolved in the sample at 50 to form a saturated solution. We're not going to get into that in this video. You can check out some other ones. Also, I'm going to put up here a link to the 2018 calorimetry and heat questions that you're going to want to go through to practice. Let's take a look here at 57. Using the information on table B, determine the amount of heat absorbed by the water when the water is heated from. All right. We're using, of course, table B, where you need the specific heat capacity. Why do I need that? If I want to determine the heat or the Q, I need the equation Q is equal to MC delta T. Remember, the heat equations are on reference table T, and the specific heat capacity for liquid water on table B is 4.18. Now, you're told to determine what is going to be looked for then is an answer. M is mass. We have a 100-gram sample of water. 4.18 is our specific heat capacity. And delta T, 50 minus 20, which is 30 degrees Celsius. Plug it in the calculator and provide your answer. When you go ahead and plug in the calculator, you're going to get an answer of 12,540, and we're talking about joules here. No mention of significant figures. I would just write the whole thing down and keep moving on. This is the end of review for 2019 Chemistry Regents exam questions related to calorimetry and heat. Good luck. Keep working hard.